Good morning, students. Am I audible? Am I audible, everyone? Okay, thank you. Atul, let me share my screen. I hope my screen is also visible to you. Okay, so let's proceed. So last class we were doing the types of your chlorination, right? So chlorination, you have studied what is chlorination, then what are the types of chlorination. We have learned about pre-chlorination, post-chlorination, then double chlorination, right? So the what is we left in between that day. So it is next is your breakpoint chlorination. Okay. So let us see what is breakpoint chlorination. So actually, this breakpoint chlorination it gives you an idea of how much chlorine is added to the water. Okay, so you will know how much chlorine or how much dose of chlorine is added to the water by like this term, that is your breakpoint chlorination. So it also gives you like how much dose of chlorination is there in the water, and if you keep on adding the chlorination, okay, if you further going if you further keep on going adding the chlorine in the water, so whether that chlorine will appear as free chlorine or free residual chlorine, so it will give you the idea of that. Okay, so what happens here actually is that, like, whenever you add chlorine to the water, so just we have discussed it, I think in the last class only we have discussed that when the chlorine is added to the water, it reacts with the what? Ammonia. Okay, it reacts with the ammonia that is present in the water, and when it reacts with the ammonia, it forms chloramines. Okay, also I have shown you the chemical reactions that day. So it forms chloramines. So these chloramines, okay, so when these chloramines are formed, so these chloramines, they when you do a dpd test is, like, to measure how much of residual chlorine is there in the water. So this dpd test it will respond to it to the chloramines, okay, and it will indicate how much of your total residual chlorine is present in the water. Okay, so then what happens is that actually when you go on adding the chlorine slowly to the water, okay, and when the residual chlorine is tested, so it what it is found is that this residual chlorine, it will go on increasing. Okay, it will go on increasing as far as you add the chlorines to the water. Okay, so like then what happens that some of the chlorine, it is like obviously you are adding chlorines for killing the bacteria in the water. So obviously some of the chlorines, it will be consumed by the bacteria that are present in the water. Okay, and so the amount of the residual chlorine, it will slightly be now less than what you have added before. Okay, so in this graph you can see this graph, you can see here. So this point A, you are starting to add the chlorine in the water. So it is going on increasing to point B. Okay. And some of the chlorines, it is being used for killing the bacteria. So you see, if the addition of chlorine, it is continued beyond this point, that is point B. Okay, so the organic matters which are present in the water, it will start getting oxidized. Okay, it will start getting oxidized because the bacteria are now using this chlorines, because the chlorines are killing these bacteria, and so the this organic matters are getting oxidized. And what happens? So if you further go on increasing the residual chlorines, it will fall down. Okay, it will not increase anymore. So the curve, it will fall down. Okay, since it is organic matters are getting oxidized. Okay, and this BC, it is shown by this one. Okay, like the residual chlorine, it suddenly falls down. Okay, now this point C, it is like, it is the point, okay, beyond which if you further add any chlorine, it will appear as your free chlorine. Okay, beyond this point C, if you add any chlorine to the water, so it will appear as your free chlorine, since now nothing is being utilized by the bacteria. Okay, so this point C, it is known as your breakpoint chlorination. Okay, so this is a graph you have to remember. So in the x direction, what is the amount of chlorine you are providing to the water, and in the y direction, it gives you your residual chlorine in milligram per liter. Okay, so next we come to superchlorination. So what is superchlorination? It is a term which indicates the addition of excessive amount of chlorine to the water. So what is the dose of excessive amount of chlorine that is added to water? That is your 5 to 15 milligram per liter. So in some cases, you know, like it is necessary to add some excessive amount of chlorine to the water, and like in case of very highly polluted waters, you can say, or you know, like when there is a pandemic of you can say, or waterborne diseases is there, so in that case also you might be using excessive amount of chlorine, you have to add to the water so that the bacteria gets killed. So and like you know, it may be used when there is a bacteria in the water named the cyst of histolytica, that is causes your amoebic dysentery. Okay, when amoebic dysentery is there and the cyst of histolytica, if you want to kill, so you have to add some excessive amount of chlorine to the water. Okay, and so the amount is 5 to 15 milligram per liter. Okay, so then we comes to dechlorination, the final step of chlorination, that is dechlorination. It means you have to, when you remove the chlorine from the water, so that is known as your dechlorination, as simple as that. So, okay, so, and what are the common dechlorinating agents? Okay. Um, So the common dechlorinating agents are named as sulfur dioxide, okay, activated carbon, sodium thiosulfate, sodium metabisulfate, then sodium sulfide, sodium bisulfite, and ammonia. So all these are your dechlorinating agents. That means while doing dechlorination, if you add these kinds of chemicals to the water, then your chlorination or the chlorine will be removed from the water. Okay. Okay, so this was all about your chlorination part. Now we will come to your softening part. Okay, this is water softening. Give me a second. Okay, so what is basically water softening? Okay, what is water softening? So you have learned about the hardness that is found in the water. Yes. So when you have to remove the hardness, that is temporary hardness, or you can say permanent hardness, both the hardness, if you want to remove from the water. Okay. So that is known as your reduction or sorry, water softening process. Okay. So what it's written, it is not always essential to soften raw public supplies to make the water safe for public uses, since the normally prevalent hardness in water. Okay, so here what happens for the industrial purposes or industrial supplies of water, you know, every time it is not necessary to soften the water, but for industrial supplies the softening is very important because these hard waters, they may cause some scaling troubles in boilers, okay, and also they may interfere in the working of the dyeing systems also. Okay, so how you have how to remove this temporary hardness and this permanent hardness. Okay, so let us see. So what are the methods of removing temporary hardness? We already discussed is that if you boil the water, then the hardness, the temporary hardness, it might get removed. Okay, so if you boil, okay, suppose if you boil, so what happens, the calcium carbonate that is present in the water, which leads to your hardness of the temporary hardness of the water, okay, this calcium carbonate, it is, you know, like soluble in water. Okay, it is only soluble in water, so it will exist in water as your compound known as calcium bicarbonate. Okay, so and it easily dissolves in water containing what, carbon dioxide gas. So when this water, or when such kind of water it is boiled, so this carbon dioxide gas, it will evolve out, okay, and leading to what, it gives a precipitation of calcium carbonate. So this, you can see the chemical reaction. This is calcium bicarbonate, CaHCO3 2 plus. If you boil, that means if you give heat, so it will give a precipitate of calcium carbonate, which is insoluble form in insoluble form in water, and also it gives you the carbon dioxide gas that is going out, and plus addition of water. Okay, so this again, the magnesium bicarbonate and the magnesium carbonate, that is present in the water, it cannot be removed under this kind of chemical reactions. Okay, why? Because this magnesium carbonate, okay, that is MgCO3. Okay, just wait. Okay, MgCO3, it is, you know, like it is so only a part of it, it is soluble in water. Okay, and this boiling, by boiling, it cannot, you cannot remove the temporary hardness from the magnesium. So in that case, we can do another process that is known as your addition of lime. So if you add lime to the water also, so what happens is that this hydrated lime, that is your CaOH2, it is added to the water, and these three reactions, as you can see, these reactions takes place. Okay, so what is happening here is that, so your magnesium hydroxide, first when you magnesium carbonate, it is added with lime, that is your hydrated lime, that is calcium hydroxide. So when you add it with this chemical compound, so what is forming, magnesium hydroxide is forming, which is a precipitate, plus also calcium carbonate is giving precipitate. Okay, so again, when you add the hydrated lime with the magnesium bicarbonate, so again, what magnesium hydroxide is giving as a precipitate. Okay, so in this kind, so at last, in the final step, you can see calcium carbonate is precipitated out. So this calcium carbonate and the magnesium hydroxide, it can be removed in the sedimentation tank by the addition of lime. Okay, so these two processes, by boiling and the addition of lime, you can both remove the only the temporary hardness, not the permanent hardness. Okay, so now coming to what are the methods for removing the permanent hardness. So if you can't remove the temporary hardness, if you can remove the temporary hardness, so there might be some ways to remove the permanent hardness also. Okay, okay, so there are, you know, like some methods to remove the permanent hardness, which are, number one is your lime soda process, number two is your zeolite process, or also you can say as base exchange process, and number three is your demineralization. Okay, so from here, number one and number two is important. You have to study, you can study number one and number two. Okay, so lime soda process, here what is happening from the name itself, you can say that there is lime and there is also soda ash. Okay, so in this process, your lime and the soda ash both are added to the hard water. Okay, so which will react this with the calcium and the magnesium salts, and it will form some insoluble precipitate of calcium carbonate and magnesium hydroxide. Okay, so these are the chemical reactions you can see. These are the chemical reactions that are taking place. Okay, so your calcium carbonate is precipitated out, the magnesium hydroxide is precipitated out, and again this magnesium uh, hydroxide is precipitated out. So these are the chemical reactions. Try to remember the chemical reactions. Okay. Again, these are again there. So it is a long step. Okay, it's a long step. So it's giving a precipitate of like calcium carbonate and magnesium hydroxide. Okay. So from this reactions, okay, you can see that in removing the entire like the carbonate hardness, okay, this reaction, so you can see, so for removing the carbonate hardness this that is like caused by this calcium as well as the magnesium that is present in the hard water, so it reacts with the non-carbonate hardness of magnesium to convert the same into the non-carbonate hardness of calcium. So both this calcium and magnesium hardness are converted. Okay, so this non-carbonate hardness of this calcium is finally removed by soda. Okay, so you have seen this calcium carbonate is finally the precipitation is calcium carbonate. So the non-carbonate hardness of the calcium, it is being removed by the soda that you have added. Okay, so this is the process of your this lime soda process. Okay. Okay, so now when you add lime soda to the water, there are some certain advantages of it. Okay, and also some disadvantages also of the lime soda process is there. So what is the advantages? You see, this process is, first of all, the process is very economical. Then you can say it is like it can easily be combined with the usual water treatment methods without much extra trouble or cost. That means you can use this while you have checked the hardness test, so you can do it in that similar way to remove the in the normal treatment water methods. Okay, water treatment methods you can add, and there is not much cost about this. Okay, there is not extra cost. And then when this lime and soda are added to the like the coagulants during the process of softening come coagulation, lesser quantity of coagulant is generally required. So whenever you are using this lime and soda process in the sedimentation coagulation process, so the very less amount of coagulant you have to use in the process in the treatment process. So this treatment, it leads to the increase of pH in the water also. And if the pH is like increased in the while in the treatment process, so there is very less chance of corrosion in the distribution pipes. Okay, then again, uh, the increased causticity may also sometimes help in killing pathogenic bacteria. So since the pH is increased in this process, so it might also help in killing the bacteria that are present in the water. Okay, and this will happen when the alkalinity caused by this calcium and magnesium hydroxide up to 20 to 50 milligram per liter is retained in the treated water for about 4 to 5 hours. So that means the alkalinity that is caused by this calcium and magnesium hydroxide, okay, if 20 to 50 milligram per liter of this calcium and magnesium hydroxide, it remains in the water, okay, in the treated water for about 4 to 5 hours, then you can say that it helps in removing the or killing the pathogenic bacteria in the water. So this treatment, it also helps in reducing the mineral content of the water. Okay, it helps in removing the mineral content of the water also, and also it helps in removing the iron and manganese from the water. So these are the seven are the advantages of using the lime and soda process in the water. So next is your, what are the limitations of lime soda? So a large quantity of sludge, that is, what is the sludge? That is the insoluble precipitates of calcium carbonate and magnesium hydroxide. Okay, so the precipitate is known as your, like, the sludge. So a large quantity of sludge is formed in this process, which must be like disposed of by some suitable method. This sludge may be discharged into the sewers or may sometimes be used for raising low-lying areas after drying. So what it is said here is that the sludge that is produced, like in this process, the insoluble precipitates of this calcium carbonate and magnesium hydroxide, this sludge, it has to be, discharged into the sewers, okay, or if you have to throw it in some low lying areas after the sludge is dry. Okay. Next is your, like, you have like very careful operation, and only under the supervision of some skilled laborers is required in order to get the good results for this lime soda process. Okay, and one disadvantage is also there is that, like this, the pipe walls of the distribution system, it may corrodes, okay, or incrustation may takes place, like if the water it is not properly recarbonated. Okay, so that is one, like, disadvantage also. And this process, this lime soda process, is cannot help in producing waters of zero hardness. That means if you also, though you are using the lime soda process for removing the hard water or the permanent hardness, for removing the permanent hardness, you cannot expect zero hardness from the water after using this process. Okay, so that is one disadvantage, you can say. So this is your lime soda process. So next we come to the zeolite exchange process, or the base exchange process, or it is also named as your cation exchange process for removing hardness. Okay, so here basically what is done, like zeolites are used. Also, what are zeolites? So zeolites are, like it is, you can say some salts, or also you can say some clays, which are hydrated silicates of sodium and aluminum. Okay, so these are the natural salts or clays which are hydrated silicates of sodium and aluminum. Okay, and they have the general formula of this one. You see this, this is the general formula for this zeolite: Na2O, Al2O3X, SiO2Y, H2O. Okay, so this is the, like a general formula for zeolites. And here, what is X and Y? These are some of the values. Okay, so the value of X is 2, it can be 2 or more, and that of Y, okay, and Y is also the same. Okay, there's 2 or more. So this naturally, some of the zeolites that are occurring naturally, okay, these are substances, okay, they are manufactured synthetically, okay, they are also, like, these zeolites can also be manufactured synthetically, and they are known as resins. Resins are what? Naturally occurring zeolites, like substances that can be manufactured synthetically. Okay. These zeolites or the resins, they have the excellent property of exchanging their cations, and hence during softening operation, the sodium ions of the zeolite get replaced by the calcium and magnesium ions present in hard water. That means this zeolite or the resins also, you can say, they have when the chemical reactions takes place, so the like the sodium ions of this zeolites, they get replaced with the this calcium and the magnesium ions that are present in the hard water. Okay, so this reaction, you can say this reaction is is your this zeolite chemical equation that is taking place. This Na2Z, this Z, it is what? It stands for the complex zeolite radical. Okay, so as a whole, it is known as your sodium zeolite or active zeolite. Okay. So when it reacts with the calcium or the magnesium salts, it can be either calcium bicarbonate or calcium sulfate or calcium chloride or magnesium bicarbonate, magnesium sulfate, okay, or magnesium chloride. So when it reacts with the sodium zeolite or active zeolite, so it will give you the sum of the sodium salts of which don't cause the hardness. Okay, and also in addition to that, it will give your calcium or magnesium zeolites, which like the exchange process takes place. Okay, so this whole, it is the reaction that is taking place. Then in this chemical reaction, that the calcium and the magnesium zeolites, that is this, so when this is formed, it can be regenerated into active sodium zeolites. Okay, when you treat that solution or this zeolites in by 5 to 10% solution of sodium chloride. So when you add or you add the sodium chloride solution to the this calcium or the magnesium this zeolites, so you will be getting some active sodium zeolite. Okay, so that is a regenerated form. So you are getting Na2Z plus CaMgCl2. Okay, so this is the final reaction which you are getting. Okay, so now we are having some again disadvantages and advantages of using your zeolite softening process. So what are the advantages? So here so when we say that when you use the lime soda process, you cannot expect the water to be of zero hardness. But when you use zeolite exchange process, okay, zeolite ion exchange process, so here you can expect the water to be of zero hardness. That means you can completely remove the hardness from the water. Okay, and you can use the water for some specific uses, like you can use for textile industries or boilers. Okay, so incrustations will not happen and all. Okay, so this plant is compact, automatic, and easy to operate. So the zeolite exchange plant is very compact and it is automatic and no need of any skill supervisions, and it is very easy to operate. Then here no sludge is formed. Okay, and also there is no problem of sludge disposal. Then the running maintenance and operation cost is also very less. Then also it removes ferrous, iron, and manganese from water. So there is no difficulty in treating the water of bearing quality. So whatever these advantages we had in the lime soda process, so all those are solved by this zeolite exchange process. Okay, and also there are some disadvantages for using this zeolite exchange process, is that this process, it is not suitable for treating a very highly turbid waters. Okay, because like this suspended impurities that you gets deposited around the zeolite particles, and thus causing obstruction to the working of the zeolite. So what is happening here is that when the turbid waters are there, so in turbid waters, what happened? We have the suspended impurities. Okay, many suspended impurities are there. So when you do the zeolite exchange process for very highly turbid water, so the suspended impurities, they gets deposited around the zeolite particles. So in that case, what is happening, that it is giving some obstruction to the for the working of the zeolites. Okay, so that is one disadvantage. Next is your the process, it leaves sodium bicarbonate in water, which cause priming and foaming in industrial or boiler feed waters. So it when you are doing the chemical reactions, you have seen that it leaves your sodium bicarbonate in water, and that will cause, like foaming in some industrial and boiler feed waters. Okay. And also number three is the zeolite process is costlier and unsuitable for treating waters containing iron and manganese. So if the water it is like there is iron and manganese, so it is zeolite process, it is not suitable for treating that kind of water, and it is very costly. Okay. So these are, like the disadvantages for your zeolite exchange process. Okay, so 5 minutes is left. So today up to here only I will be doing, because from 11 I have some, like meeting I have. So I can't do this 11 a.m. class. I cannot do. So let us keep up to here today. So only I need one class for, completing the water treatment part. Okay, that is I think your module 3. To complete the module 3, I need only one class. So after that, we can uh, start our sewage part. That is module 4, we can start. Okay. So next Tuesday, I will be completing your this water treatment part. Okay. So you give your attendances in the group. Okay. WhatsApp group you give. Okay, then you may leave the meeting. I will share this note in the group. Thank you.